Okay, we finished with contraction. Now we're going to start with relaxation. So if we scroll down, we're going to see this figure right here. We can see that there are three main things when we need to relax. Number one, the contraction happens because we release the neurotransmitter acetylcholine. Then calcium gets released to trigger the activation of troponin and tropomyosin. Then, in the presence of ATP, myosin attaches to actin. Okay, so then how do we relax? If they are attached, we need to separate them. So we're going to use ATP in order to separate that. And that way we stop the contraction and we relax. Next, calcium gets released. So how do you stop the contraction then? You reabsorb the calcium back into the blue containers. Next, acetylcholine gets released. What you're going to do? You reabsorb the acetylcholine back into the nerve. In addition to that, in the synaptic cleft, there's an enzyme. It's one right here. This enzyme is called acetylcholinesterase. And this enzyme is going to destroy the acetylcholine. So if there is no acetylcholine, then there's no more contraction. So then, how many steps then we need in order to get relaxation? We need the enzyme called acetylcholinesterase, as you can see right here. Or we reabsorb the acetylcholine back into the nerve. Step number 2, we reabsorb the calcium. And step number 3, we use ATP in order to separate myosin from the actin. That's about it. Okay, if we scroll down, we get to the next concept, which is the length-tension relationship. Basically, this means that the best contraction that you're going to get depends on how your muscle is. If it's overly stretched or overcontracted, it will not get a good contraction. So if there is an optimum resting length, which is going to give you the best contraction. So let's keep scrolling down, and that's about it for this part. The next topic is behavior of whole muscles. Right there you have threshold, latent period, and twitch. We need a nerve in order to make a muscle move. But not all the stimulus that a nerve is going to produce is going to make a muscle move. It needs certain amount and certain strength in order to achieve that. Sometimes the amount, but just barely amount of a stimulus will produce a twitch. The twitch is this sensation that you have sometimes near your eyelid, right, that it moves a little bit. It doesn't perform any type of work, but it's a contraction. Okay, so it says in the contraction strength of twitches. You can get a twitch with a muscle and an electrical stimulus. So everything that they do with twitches is done most of the time in labs. If we scroll down, we can get right here. And here, for example, they change the strength. You see they increase the strength, and look at the muscle contraction. You see it increases? And if we keep scrolling down, we can get to the other one, where you can see here they change the frequency. For example, they stimulate the muscle every hour. So you can see here contraction and relaxation, contraction and relaxation. This is every hour. This one right here is every 10 minutes. And this one, let's say, is every minute. You see, you can even see the contraction in here. Okay, we keep going. And the other type of contractions that we have are going to be isometric and isotonic. Isometric, iso means the same. Metric means length. So imagine that you are pushing a wall. Your muscle length will not change because you can't move the wall. So in this case, do you produce a force to move the wall? Yes. However, did that length of your muscle change? No, because you were not able to move the wall. And this is called isometric contraction. The other one is isotonic contraction. Isotonic contraction is when you produce the same amount of force all the time. For example, this person right here, she's lifting a dumbbell, and in here she's putting it down. If let's say this dumbbell is 5 pounds, if she produces in this muscle 5 pounds, she's going to be able to put this down on the floor. But if she lowers the 5 pounds and produces only 3, this will drop to the floor. So then that means that if you want to produce a movement in which you can actually put the dumbbell on the floor, you have to maintain the same force, otherwise this will drop to the floor. Same thing applies in here. If this is 5 pounds and you produce 5 pounds, you're going to be able to lift the dumbbell this way. But if you produce more force, this will come out flying because you're producing more force than what you need. So these two types of contractions are going to be isotonic because you have to maintain the tone, and you have to maintain the tone. Otherwise, in this example, you will drop the dumbbell to the floor. When this comes towards you, this one is called isotonic concentric. When this one goes away from you, this is isotonic eccentric. Okay, if we keep scrolling down, let's see what else we have. That's it for this part. The next topic is muscle metabolism. In other words, what do muscles need in order to contract? As you can see in there, ATP. You have a nice graph in here where you can see that they have separated this in 3 different periods. 1, 2, and 3. So the first one is from 0 to 10 seconds, the next one is from 10 seconds to 40 seconds, and then the last one is from 40 seconds until you finish, for example, running. You need ATP in there, you need ATP here, and you need ATP here. The ATP that you need in here is immediate ATP. Here is short-term ATP, long-term ATP. Immediate ATP, glycogen system. From 10 to 40 seconds, short-term ATP, you get it from anaerobic respiration, which is going to be glycolysis. And from 40 seconds to until the end of your race, there's going to be aerobic respiration. So if we scroll down, we can see the immediate energy. So we said that is from 0 to 10 seconds. And we said you're going to get this through the phosphagen system. Which ones are the two methods for the phosphagen system? One of them is myokinase, and the other one is creatine kinase. So these two are going to be able to produce ATP for the first 10 seconds. This is called immediate energy. We keep scrolling down. The next one is short-term energy. This one is from 10 seconds to 40 seconds. And we said that this one is going to be through anaerobic respiration. That is step necessary in order to create this glycolysis. And you produce 2 ATPs. The next one is long-term energy. Long-term energy is from 40 seconds until you finish running. In this case, this is going to be aerobic respiration. And this produces 36 ATPs. Next topic, fatigue and endurance. You get fatigue because you use your muscles too much for a long period of time. For example, if you're running a marathon, then you're going to get fatigue because you use your muscles too much and for too long. What reasons produce this fatigue? Potassium accumulation, ADP accumulation. Now, excess post-exercise oxygen consumption. When you're running, for example, a marathon, at the very end, you are very tired. Are you breathing properly? No. So you are not getting the oxygen that you need. So you owe your body oxygen because even though you're running, you're not getting the amount of oxygen that you need to keep running. So you owe your body oxygen. What happens when the race finishes? This happens. You start breathing very fast when the race is over because you need to repay that oxygen that you were not breathing when you were finishing the race. And this is called repayment of oxygen debt. And that's what we have right here. Again, when we scroll down, oxygen debt, and you pay that oxygen debt by breathing very, very fast at the end of the race. The next topic is physiological classes of muscle fibers, and we have two. As you can see here, the first one is a slow twitch or a slow oxidative type 1. If this one is slow, and you can see right here, then the other one is going to be fast. So if we keep scrolling down, right here you have fast twitch fibers or fast glycolytic or type 2B. Let's keep scrolling down, and we can see that in here. You can see are fast, are clear, slow, or dark. This is because muscles are going to have different characteristics because they're going to perform different type of activity. For example, we have gastrocnemius help us, for example, to jump, but the soleus help us to stand up. So the gastrocnemius, which is for jumping, you're going to have more of these light pink fibers. The soleus, which is going to allow you to stand up for a long period of time, is going to have more of these dark fibers. Okay, let's keep scrolling down. Muscular strength and conditioning. Strength and conditioning depends on how you are going to exercise and how you're going to use your muscles, and you're going to get more by using your muscles more frequently. And how do you achieve that? Well, you can use resistance exercise or endurance exercise. Resistance exercise is against some weight, for example, when you lift weights at the gym. And endurance is, for example, when you run. And which one is more beneficial? Well, none of them alone is better when you do what it says right here, cross training, in which you do part of resistance exercise as well as endurance exercise during your daily physical activities. And that's about it.